if you have any confusion, any doubt up to the last class, you can ask. Okay. So in the meantime, your some of the friends will be joining. I don't know why they are taking time. Okay, so no one have any doubt up to the last class. So then we'll start. Okay. So in the last class, we have discussed about the straight line motion mechanisms and then about engine indicators also already we have discussed. So today we'll be discussing about the automobile steering gear mechanism. So all of you already know the purpose of having a steering in any kind of automobile. So basically this particular steering gear mechanism for what purpose we use. So this mechanism it changes the direction of motion of the generally the front wheel so that the vehicle moves in a desired path. So all of you already know that means each and every time we don't have we are not only going in the straight line motion, okay, or in the forward direction only. We have to take those curves, we have to take different alternate routes, etc. And for that proper steering is necessary. Okay, so we should be able to steer the front wheel so that the vehicle takes that desired path. And depending on how much actually what is the steepness of this particular or the curvature of that particular radius of curvature of that particular turn, depending on that that particular value of the steering, okay, how much you are going to steer, that also will differ. Okay, now some of the basic criteria which should be fulfilled for a proper steering so that there is no skidding, no whirling of that particular uh, vehicle enhance. Okay, so for that, when an automobile takes a turn, so one important criteria to remember is, so here all the wheels should make concentric circles. And so that when if it is making concentric circle for a level, it will ensure that they will roll on that particular roll smoothly, and there will be kind of line contact between the tire and the surface of the particular part. And if that is going to happen, so then there will not be kind of any heavy wear and tear on that particular wheel. Okay, so what happens if I consider this to be kind of wheel? Okay, so let's in this particular figure we are showing, suppose this is the chassis of that particular vehicle, and this is the front side. Okay, and this side is the rear side. Okay, so this is the back wheel or the rear wheel. So we are showing just four wheels here. One, this is another, and we are showing the vehicle taking a right turn. So in that particular case, this is one, and this is another wheel. Okay, so now we know that that particular wheel, okay, that particular vehicle, it has also got a certain, okay, so it occupies certain space. And now one of the wheel will be here, another wheel is here, okay, generally mounted on the axle. So now what happens, so when taking that particular turn, when these wheels are actually making concentric circles, okay, all the wheels, so in that particular case actually our expectation is, so the wheel should keep on rolling on that particular surface. Okay, and there should be, for less wear and tear, there should be kind of line contact between that particular, if I consider this as this particular wheel, okay, I'm showing half of the wheel portion. Okay, and this is the road surface. Then here we have got the, you know, like contact, and throughout the thickness of this particular or the width of this particular wheel, if you consider, okay, then throughout this we have got the contact. That means it's expected it is line contact. Okay, and if it is line contact rather than a kind of surface contact, so it is going to prevent excess wheel wear. Okay, so that means the line or longevity of that particular wheel also will be. Okay, so now what happens you see? So if we are thinking of taking this particular turn, so we are talking about right now right turn. Okay, so if this is this particular road is having this particular curvature. Okay, and we are taking this particular right turn. So in that case what happens, so both the front wheels which are being steered, they should be they should move by somewhat different angle. Okay, like that means this particular angle turned by inner front wheel and this particular angle turned by the outer front wheel will be somewhat different. Okay, the value will not be exactly the same, but for proper steering, as it has to, if we think of this particular extended position. Okay, if I just this line, if we extend, so now if you see here, from here and here, actually in some short axle, this is the portion, short portion, smaller portion. In this short axle, actually the wheels are mounted. So I'm saying that both the wheels should be able to turn by angle which are different. Okay, so the inner front wheel is going to turn by a somewhat more angle, and the outer front wheel has to turn by somewhat lesser angle, because you see this is the instantaneous center of rotation position for this particular case. Okay, so this is the wheel position. Okay, I have extended, and this one is this. Okay, so now this is the instantaneous center. So that means I can consider, while taking that particular turn, as if the whole body is rotating about this. Okay, taking the turn about this particular instantaneous center. Okay, we can assume like this. So this is not a actual center. Okay, that actual center means physically it is not present, but like, but as if it is like this had caused the importance, because with respect to this location, actually I can consider the whole body is taking that particular turn. Okay, so after this was understood. So now that means our intention is now uh, the both the wheels should be able to take the turn or make the angle, and that angle will be different. That means theta, this is theta and this is phi. Okay, so theta is not equal to phi. Now we must know that means they, I know that they are not equal. Okay, now we should also know that means how they should be related, so that I can consider like we are having a proper turning. Okay, so now one thing, it is not equal to that theta is not equal to that particular phi. Okay, so now that means what will happen, if this is the front wheel, this is another front wheel. Now whenever this is taking the right turn, I think of, once again I am just making this. Okay, I'm just showing the front portion. Okay, so whenever it is taking right turn, so what happens, this wheel also will get rotated by a certain angle depending on what it is. Okay, and this wheel also will get rotated by certain angle. Okay, now in that case, right turn means this is the radius of curvature, so this side becomes inner side, this is the inner side. Okay, so this front wheel I will call that inner front wheel, and this is the outer side. Okay, so this is the outer front wheel. Okay, so both are front wheel. So similarly, these two are the rear wheels. Okay, so up to this part, I hope it's okay. Now we know they have to turn by some different angle. So now for that, what happens? Now we know that these two rear wheels, there the axis of the rear wheels are fixed with respect to this particular chassis of this particular vehicle. And now to facilitate this particular movement, this particular different angular movement, so the two front wheels are actually mounted on two short axles, and they are known as the stub axle. So sometimes it is asked what is the usefulness of stub axle, why it is required. Then you should be able to say that like what is the logic that means both the wheels should rotate by different angle for correct steering, and for that to happen, we are actually some pin joint we have, okay, here, and this is one axle, it is pin jointed here, and this is another stub axle. So two stub axles, okay, short axle known as stub axle, these are pin jointed to the match. And when the vehicle is making right now, if you are thinking of the making the right turn, okay, then the front wheel of that side must swing about the pin, which where the angle is greater, okay, which to a greater angle than the wheel on the other side. That means this angle phi This is the inner side, okay, and the theta. So, sorry, not phi. And this is the phi, okay. Then theta has to be greater than the angle phi, okay. And in the ideal relation is that the instantaneous center, I have already shown the instantaneous center position I, okay, it is denoted by I of that particular front and back wheel. They must coincide on the common axis of the two rear wheels. So as you can see, so these are, this is the, this is the, if I extend the rear wheels, then this side it will move, and so all the, for the front wheel as well as for the back wheel, the instantaneous center is this, okay. Up to this much, any confusion, anyone? After this one, it is clear. I hope the logics are clear. Okay, okay, thank you. So, okay, okay. So now we are going to see, now these things are known. That means what are the importance of it, well, how it is going to, like whether it should roll and whether it should have what kind of contact it is expected. Okay, for what purpose and all. Okay, similarly, what the angles and all. Okay, why the both the angles are different. Okay, and to facilitate two different angular movement, what we provide, that is the stub axle. All those things I hope is clear. So now we should know, that means now we know, that means this is the, this type of thing, this type of thing it is happening. So now this is known. So now this knowledge is known, but now we must also know, that means what is the, what should be the relationship. Okay, how like if suppose this is the curvature of that particular turn, then what should be like the, what should, how much the steering should rotate with its outer wheel or outer inner wheel, or depending on if what is size of that particular car also, okay, it will be dependent. So like that. Okay. So now we are going to deduce a very small relationship, important equation. Okay. So now let's consider small a be the distance between the pivots of the front axle. That is this. Okay. So pivot of the front axle means this and this, and this distance we are considering as small a, and b is the wheelbase, and step small c is the wheel track. B is the wheelbase. That is from the distance between the front wheels and the back wheels, that is known as the wheelbase. Okay, and wheel track is what the, you can consider like as if the wheat, okay, where they are located. So wheelbase. Okay, so now wheelbase gives you the indication about the length of that particular car. If suppose this is the, let's consider this is the kind of car, okay, very basic car that we used to draw in your rally when you're in like KG1 or something like that. Okay, so this distance is speed difference. Okay, now from the back side, if I look at this particular car, let's consider it looks something like this. Okay, so these are the tail light. So this distance is, okay. So basic see, okay, and throughout the mechanism, if you say basically, where actually the distance between these two pivots are the A, okay, and C is generally bigger than A. Right now, here in this figure, it looks something like this. A, it may get confused, but if ultimately throughout the mechanism, if you say somewhere in the front side, okay, this is if we think of that front side, then there will be those kingpin, etc. All those things are there. If you to that. So in that case, this must becomes A. Okay. So forget about that. So you must know that this is the wheelbase. This is filter. Now, if I consider angle triangle BIE and AIE, that is we have just extended already. Extended center position is obtained. Okay. If I join this, if I drop this perpendicular, so we can consider these two triangles AIE and BIE. where it encompasses both the angles theta and phi. Okay, these two triangle encompasses this, and this is right angle triangle. Okay, so from here we can use that particular just trigonometry. Okay, so what will happen? Cot phi equal to BE by IE. So cot of this angle will be PE by IE. Okay. So all of you already know that some people have that curly brown hair, black hair turn permanently like that. How to find out that all those things. Okay. So similarly from the other angle, I can get cot phi to be AE by IE. Now what I can write, AE equal to this, AE is equal to AB plus PE, right? So I can write like that. So we can write A equal to that AE AB plus what, PE, right? So now that I can write like this, AB by IE plus BE by IE. Already, so these things are already considered. Okay, AB is considered as distance between the pivots is considered as small a. IE is once again IE. This itself is equal to B. Okay, I equal to B, A by B plus once again PE by IE was cot of theta. Okay, so from here what I can write, cot phi minus cot theta equal to A by B, and this is very important equation known as the fundamental equation for correct steering. That means if this relation holds good, then you can expect that whatever correct steering mechanism you are making, that is correct, that will be correct, and it is going to behave exactly uh, as it was intended. Okay, and those mechanisms which fulfill these fundamental equations are known as the steering gear mechanism or steering gears. Okay. Now the thing is, you just should not only remember like cot phi minus cot theta equal to A by B. So you must also remember what was A, what was B. Okay, and what is phi angle, what is the theta angle. So theta angle is the inner side, okay, inner front wheel, whatever angle it is making, whatever turning it is taking, that is the theta, and for the outer one it is phi. Okay, and what about AV? Okay, A is the distance between the stub axle. Okay, no, not the stub axle, distance between the front pivots. Okay, and B is this wheel base. Okay, so this is very important. Understood how we have derived this? Very easy to derive, but you must understand. Let me know something. So this is the steering gear mechanism. Yes, all of you have understood. Okay. So now, as I was saying that different, that is the fundamental equation for correct steering, and we have got like different mechanism which follows this. Okay, so we have got two basic type of steering gear mechanism, that is known as the Daly steering gear mechanism, and another one is the Ackermann steering gear mechanism. So both of them follows this fundamental equation of steering. So they are steering gear mechanism. Okay, so now what about this type of steering gear? So we are just showing the front portion. Okay, so we already know this is the front wheel. We are just showing this is the front wheel, one front wheel, another front wheel. Here it is pivoted, so this much is the stub axle, that means. Okay, and in this mechanism, okay, what happens? It consists of two arms. This AG arm, okay, and this BH arm, which are fixed to the stub axle. Stub axles are the smaller axles, which allows the differentiated movement of angle. This wheel C and wheel D. Okay, two angular. So and they forms this particular lever known as Pelgrim lever. For symbolic structures like this. Okay, and here we have got one link, that is EF link EF. It is known as the cross link, also known as the tracker, and it is constrained to slide parallel to AV. That means wherever this is work. Okay, so I will be giving some guides here so that it can only slide along this direction. It cannot go in different direction because we will be providing some guides. Okay, and once again that particular E F, okay, these two positions, EF is pin jointed, and at these two positions E and F with this particular slider S1 and this particular slider S2 respectively. Okay, and this slider S1 can slide here in the AZ, and this particular slider can slide here in this link, okay, PH, okay, and this P and Q, this P and this Q, they are nothing but the sliding members, okay, which constrain the link. That means they are kind of the guide, you can consider like that. Okay, now during the movement of the vehicle on a straight path, so there is no need of, is there any need of steering if you are going in just in a straight line fashion, no turning and all? During that time actually it is not required, but but each and every time it has to be there, because at any moment of time we might have to steer that vehicle, okay, so that's why okay. So now if it is in the mean position, that means it is just going forward, so this angle and that angle is my, okay, that is alpha angle. And let's consider it's just taking a right turn, so this is the front portion, this is the back portion, and the front side whatever is happening that is being exaggerated in the lower figure. Okay, so now whenever it is taking a right turn, okay, previously the wheels were here and here, these are the two initial position. Now when it is taking this particular turn, so as this was the bell crank lever, so it from this side it is moving up to this side, okay, and from here it is moving up to this side, and this EF link can slide, we have already said that it can slide, okay, in this direction, so it will assume now this dotted line position, okay, and that means some shifting is there and some angular value has changed, okay, previously it was alpha angle, now alpha plus phi 1, that kind of angle it is happening, okay, so one case is this side, another side is this side, okay. Now just from these two figures, if you just do the analysis, okay, just take the uh, already we have considered a is the distance between the two figures, so the important things are the h and x, okay, the h is vertical distance between AB and EF, that is this mass, okay, this mass is h, and what is x, we are saying that whenever it is taking the right turn, the crosslink EF, this is the crosslink EF, it moves to right by a distance x, okay, this mass distance, that means it has shifted from here to here, okay, from the matrix, so that is x. So if you, after that, if you just from that particular triangle f dash f double dash b, if you just take the tan of this angle alpha minus theta, that is happening here. Okay, so this angle is alpha minus theta. Okay, so if you just take that and just do the simplification, then what you will get, you are going to get y by h equal to a by 2b, or ultimately tan alpha is equal to a by 2b. Okay, that's it has already been shown, simplification is already being done, all of you can just go through it. Okay, so in general what happens, the value of alpha, that is in the mean position we are seeing now, it is already making an angle, this angle is alpha, okay, or you can say from here this angle is alpha, this angle, okay, in the mean position whenever the vehicle is not taking any turn, whatever angle it is making with the vertical, this angle is alpha, okay. So generally the alpha value is like 11 degree to 14 degree is the standard, and this ratio a by b, not a by 2 hp, a by b is generally it lies from within this particular limit to of 0.4 to zero point 0.5, okay. But the thing is, here as I have seen that there are so many like the sliding pairs are involved, so if there are sliding pairs, so ultimately there will be high friction, high level of friction, more wear and tear, so there will be loss of the accuracy of the steering gear mechanism after some time, that's why it is less common in use. And the better version of the steering gear mechanism, where mostly we see some advantage over the Davis steering gear mechanism, is the known as Ackerman steering gear mechanism. So as you can see here in this left hand side figure, so the mechanism of steering mechanism is placed in the back side, okay, within that particular space. Yes, it is not extended in the outside. So here it's also consists of like basically four links, so PAPQ, having all this and this, these are all turning pairs, ultimately pivoted, so turning pairs. So PA and this QB, they're equal in length, okay, and they're fixed to the star axle here, okay. So and because of that, this side, okay, that way, this way, and this way, it is forming two bell crank levers, okay. And here this is the AB is the crosslink, and once again it is pin jointed at the ends of this pale crank lever. Okay, and once again, just like in the previous case, if there is no like it is just in the normal this not being turned, okay, in the straight line motion only. So the gear is in the mid position with equal inclination of the arms. It's PA and PB. That means both the angles are alpha alpha. Okay, and this AB link is parallel to the initial, that's PQ in this mean position. Okay, but whenever some turning is there, definitely these angular values are going to change. Okay, so but the thing is, one important thing that you must know is there are certain basic positions where the Ackermann steering gear is fulfill going to fulfill the fundamental equation of correct gear, but not yet all the positions. Okay, so now what happens? Once again, if you think of this is here we are showing the how the Ackermann steering gear is working. So this L-shaped links that you have seen, these are nothing but this shape is known as the bell current lever, where we have got pivoting here and here. This is the cross link, and this is the actual whatever is the access position. Okay. So now here what happens? So this we are going to design that, okay, right? So we are going to design this particular function. So uh, if we know what is the value of that particular this angle alpha, okay, so will be and the angle of the link length, okay, then we'll be able to draw that, okay, as per suitable position. And for that case, by doing some experiment, so that is if I rotate by this much amount, how much is the angular deflection, or what is with the value of alpha phi, those things we can note down for various theta values, right? So if this much angular movement I give, okay, what is the outer angle? Okay, so now what happens? These theoretical values of this phi for different values of theta, that also can be obtained if we know about the a and b values. And generally that value is obtained as like if you use the correct theory, fundamental equation of correct gearing, that is called phi minus cot theta, which is equal to a by b, generally lies within this value, okay, for a Ackermann steering gear mechanism 0.455. And now we are saying that theoretical value will be there, and practically also by experimentation we can get something. Okay, so generally what happens if you actual and theoretical values of phi, if you just consider, generally for smaller values of or the smaller turning, so the actual value is marginally higher than the theoretical value. Okay, but whenever you are taking larger values of theta, that is the sharp turning, then actual value of phi is lower than theoretical and substantial. Okay, that means some problem. But the thing is, whenever we are thinking of actually, this might sometimes create a problem. Okay, so now that's for what happens if we are thinking of taking a very high sharp or sharp turn, that is higher value of theta, then the wear and tear on that particular tires can be more due to slipping action that is going to happen on the tire. Okay, that's why we should not take sharp turns. Apart from that, in actual case scenery, if you think of, then that is the practical road scenario. Then what happens if you are thinking of taking a turn without causing accident and all? So our general practice itself is to slow down that particular value and slow down that particular car. Okay, and because of that actually whatever is the for this high wear and tear that we have obtained because of theta, okay, that can be somewhat reduced. Okay, and it doesn't affect that much life. Okay, so now one thing that you know sometimes it is asked is, in case of economic steering gear, the eye center, that is the instantaneous center, it is not exactly on the rear axis, but it is lying on a line which is parallel to the rear axis, but almost 0.3b above it. So that means, as you can see here, so in the previous case, Davis gearing gear mechanism, you have seen it was up to something like this. Okay, in case of Davis steering gear mechanism, so if we extend this particular angle, so it was behaving something like this. The instantaneous center, that is the imaginary center about which it is moving. But right now you can see like exactly it is not here, but actually it is lying at a somewhere parallel to the rear axis, but at a distance 0.3b, 0.3b from the rear axis. Okay, this passes the distance. Okay, it is above it, not exactly. Sometimes it is just okay. B is the wheel. And the three positions of correct bearings are like when the vehicle is moving straight, it is okay. Then when it is moving at a correct angle to the right, then also the it fulfills that particular equation of correct steering. And when the vehicle moving at a correct angle to the left, okay, so there will be proper. It will be getting through that particular whatever is the correct steering. Okay, and if you need to find out the angle alpha, then using this particular relationship you'll be able to find out the angle alpha. Okay, where already we know theta and phi are the values for correct steering. Okay, so now what are some of the advantages why we are saying that it is being the daily? So one of the advantages, as you can see, the whole mechanism of this particular mechanism is in the back of the front wheel. Okay, so as you can see here, so in this from this particular figure, so the basic mechanism is in the back side of the front wheel. Okay, this is the front wheel. This is these are the rear wheel. Okay, so because of that, the extra space saving is there. Okay, so it will not be somewhat bulky compared to that one. Okay, but the steering wheel here, it is somehow it is not in the inside of it. Apart from that, as you have seen, only we have got the like only the turning pairs. Okay, all those turning pairs and all. Okay, pin joints. So turning pair only. Okay, so there is no sliding members just like in the Davis match. So there will not be any. Like there will be reduced wear and tear. Okay, and original accuracy will be maintained. So with this, we'll stop here for today. So in the next class, we'll be discussing what universal designs, application and all. Okay, also known as the hook design. So we'll see different cases of it, and after that we'll see about your double hook design and some intermittent muscle memory. Okay, so we'll stop here for today. So let me know if you have any question in doubt.
So you will say, providing this recording to us, right, sir?
Yeah, are you there in the Google Classroom?
Yes, I am there.
So are you following the updates in the Google Classroom?
Yes, sir. So I will see. I will
If
check it
yes,
today.
then you already yeah. If yes, you already know the answer.
Yes, sir.
Seems like you have not checked it. Okay, but you, okay. So respond to your name calls. Nilotpal,
Present, sir.
Shankar,
Yes, sir.
Arshisman, Arshisman, absent. Rehan,
Present, sir.
Partho Patir, Partho, absent. Rishikesh Basumotari, Rishikesh Basumotari, Rishikesh Basumotari is absent. I think he was there. Okay, so Fairmiki, Fairmiki,
Yes,
Fairmiki, absent. Nohosol,
yes, sir.
okay,
Yes, sir.
Nohosol, present.
Present, sir.
Teza,
Yes, sir.
Teza is also present. Rishikesh Nath, Rishikesh Nath, absent. And Emil, absent. Okay, so we'll stop here. So in the next class, okay.
Thank you, sir.
Thank you, sir.
This one. Okay. Okay.